actually, soy sauce is high in sodium, so be careful. I have to watch my sodium intake. All right. First thing we want to do is talk about 2-1-1. So sorry that Satya's not here, but he vanished for some reason. So, were there any issues from 2-1-1 / do we need to review any of the triangle congruence theorems? Remember, theorems we know work. You will not find angle side side on here because that is not a way of proving congruence. Yes, you'll find side angle side. Order is very particular. So the order of these congruence theorems are based off, we start with one relationship and then go around the triangle. So side, 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 that's pretty obvious. But side, angle, side versus like side, side, angle. Yeah, this is side, angle, side because the angle is included between the two sides. The angle must be included for side, angle, side to work. If it doesn't, it's not the same thing. So angle, side, angle. Why are you highlighted blue? Whatever. Angle, side, angle includes the side. So the side falls between the two angles that have been noted to you. Even if the triangle has been turned or manipulated in a different direction, as long as I can go like 1 tick, 1 tick, 3, 1 tick, 1 tick, 3, as long as I can go in the same order and line things up, we're good.
We learned what these mean, but we never learned why we make them congruent.
We did the thing where they gave us the measurements and everything.
Yeah, but we learned like that.
So really what it comes down to, if I'm going to like boil this down, if the triangles are similar and then there's matching sides that are congruent, the triangles are congruent.
Yeah.
That's it. Like that's what it comes down to. So first we're checking, are they similar? And then if the sides line up and it makes it true, then they're congruent. So angle, angle, angle shows us similarity, but then when we throw a side into the mix, because guys, angle, side, angle is also angle, 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 right? Because once we know two angles, we know the third angle.
Oh, yeah.
So I've had students in the past make the argument like, well, then I can use like angle, angle, side. I'm like, yeah, you're right. That's why it's also a theorem. Because anything with angle, angle is really angle, angle, angle. So these are, honest to God, like the same thing. Because we know all three angles. It's just what's been given to you. You don't have to solve the third angle. It's just, have you been given the two angles and then the side, or the angle and included side and then the other angle? But with all truth, you can just solve the third angle if you want. And this is why hypotenuse leg works. This is the most commonly forgotten about congruence theorem, because we understand trigonometry, which you'll understand more as we go, and because we understand the Hinge theorem. Right? Hypotenuse leg essentially goes back to the Hinge theorem. We have a door and a doorway, right? So if I were to give you something to imagine, here's a doorway with a door that's too big to close, or a doorway that's too big for the door, something like that. If this door and doorway are open at a set angle, and this door and doorway are open at a set angle, then the distance out here will be equal to the distance out there. Hinge theorem, right? Because these two legs are the same. That comes back to trigonometry, because when we know that it is a right triangle, once you know the hypotenuses are the same, and then you have another leg, we're done. Because that sets up your Hinge theorem. Cool. And Pythagorean theorem, if you want to throw another, because Hinge theorem, I forget actually who made the Hinge theorem. Unfortunately, his name did not get kept there. But Pythagorean theorem, once we have two sides, we can find out the third side. So just like any of the angle-angle theorems are truly using all three angles, hypotenuse leg is actually just a shortcut for not solving the third leg using the Pythagorean. Because essentially we're just saying, well, we know they're going to be the same. We don't have to show it. Questions about any of those or the homework from 2-1-1? I really want to like get a pet cricket for the class. So when there's no questions, it would literally be crickets.
That'd be amazing. You totally should.
I got one of those little clicker things where you can have a head
Yeah.
on it and just made a cricket so I can carry it.
So we had a cricket stuck in our garage this is where I got the idea. There was a cricket like, trapped in the garage, so I kept going out there and hearing him. So I opened the garage like 6 inches and eventually found his way out. But I was genuinely thinking, like, man, this would be a way to make someone go crazy. Because like crickets are actually really loud, especially when they're scared. So I think it was scared that it couldn't get out of the garage. You could make someone go crazy. All right, let's get out notes. We'll actually do some work today.
Hide a bunch of crickets inside their house. Could talk about crickets.
We could talk about crickets the whole time, but I don't think the educational department of Worthington City Schools would appreciate us just
How
talking
about we
about
measure
crickets.
the length of each leg and the crickets and crickets and see if they're equal?
Yeah,
You guys are going to get a bunch of these this year.
Worked with the cricket's legs.
Yes.
Oh, that one's a hole punch. I forgot the hole punch.
Ooh, yeah, I got the first one.
So, now, as we go through lessons, especially ones that are continuation from Math 1, I really need your guys' honest feedback for whether stuff makes sense or whether we should talk more about it. So please use these graph organizers to keep track of the theorems that are new. I know, you're going to get a bunch of these this year. Because you're probably going to start to fill them up. Did I just give somebody my answer? No, I said it.
Fun
Sorry.
fact, I don't give a darn if they're shortstop. I don't give a darn if they're shortstop.
So, I'm just giving you those to use if you want. At this point from last week, and this is really comes down to like you can copy out of your math notes box, we now have determined that side, 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 angle, all of those prove congruence, and as well as angle, angle, side, and hypotenuse leg. So if you would like these in a graphic organizer for in your notes, pull out the information from the math notes box, and that's why I gave you another page of these. Now, if you don't write them down, that's your choice. If you feel as if you've already practiced them enough, or you just took Math 1 over the summer and they're so ingrained in your brain you can't take it, whatever you choose to do, that's on you. Like, that's your...
Tell me we aren't starting flowcharts.
Yes, but with a caveat. What?
Pretty sure it's pronounced caviar.
Sure, I don't know what.
Doesn't matter.
Oh, because you got my original. See? You celebrating your hole punches. There's always a way. Alright, so, my caveat, whatever.
Yeah.
I seriously think it's caveat.
I think it's
Caveat.
caviar.
It's caviar.
With flowchart proofs. Flowchart proofs are your intro to the proof world, where we don't want to strictly make you follow a 2-column to begin with, but if you prefer 2-column, that's fine. Okay, you don't have to use a flowchart. Even in the practice work, if it says use a flowchart proof, you can do 2-column if you want. The difference between flowchart and 2-column. Flowchart, you're going to have like statements, or like the reason that gets you to the statement, and then the statement that you're able to get to, like the thing that you find out, and then like what it allows you to do, and then from there you might find out more stuff, and like that's all well and good, that's great, and we'll practice that skill. However, 2-column, statement, reason. So we might say blah blah blah, this info is given to me. Blah blah blah, because the triangles are congruent. Blah blah blah, because congruent parts of congruent triangles are congruent. Like that's how 2-column differs from flowchart. My brain, how I'm like more algebraically structured, like this to me makes a lot more sense than a flowchart.
Yeah.
But that's my brain. So if you want flowchart, do flowchart. That's totally fine.
And they also flowcharts take a long time.
I just don't think they're as clean. That's my issue with them.
Right, when we have
So when we look at 12, are these triangles congruent? If so, how? They say no. I have to say no. When we look at 20, I'm not even asking you to write anything. When we look at 2-12, are these triangles congruent? Why? Are these right triangles? We don't know, right? So be careful. Do not assume things based off what stuff looks like. Guys, if we can't determine if this is congruent, I quit.
Yes.
Yes.
Nobody wanted to.
Well, yeah, no one was. I get it. So yes, right? Why?
They're the same
Anyway,
size.
side, right? They're exactly the same. But here, we've been given one side, one angle. Who can tell me what we can do for Nidden?
Make a flowchart showing your argument.
Nidden?
You do vertical angles.
Vertical angles. So if we were writing this out as a proof, and guys, even if you know something, you have to be able to defend how you know it. So we're going to skip all the given info. Okay, for this problem, I'm going to make your life easy. We're going to skip the given, but if you want a 2-column, I'm going to write given as like, okay, we see some information, right? Which are those congruent angles and congruent sides, right? That information's been given to us. We've got some given info. Then we state that angle PRQ is congruent to angle SRT. I'd love to dodge SRT. Because vertical.
Yay. We just write like E.
No. You have to at least write vert and draw the angle symbol because we cannot abbreviate everything. Then,
Why did you start with
those aren't stars, those are my angle.
no.
That means size of an
Oh.
angle. So there's a bunch of different ways to do this. You can write M angle, and that means measure of the angle, but that's the same thing as writing the angle with an arc across it, which means if I'm measuring the angle, like a protractor measurement, that's what that symbol is representing, is how far does it open. As opposed to if we're just naming angles, you can just put the angle symbol, but I'm saying the size of this angle is congruent to the size of that angle. What can we say now? Angle, angle, side, right? We've got here. Now, here's the most dangerous part, and what every year people miss on the mastery for this test. The order you write the triangles in makes or breaks whether your statement's actually true. So as I go in order, if I start at P, then go to R, then go to Q, I've started at my 120-degree angle, I go to my vertical angle, and I go to my unmarked angle. So I then have to start at the same location, T, go the same direction to the vertical, and then go to the unmarked. So this becomes T, I need the triangle symbol. Triangle TRS. Now notice that's different than the congruence statement that I had above there. Because for the angles, who cares about the order? That angle is equal to that angle. Great, wonderful. All we really care about is the vertex. But because they shared the same vertex, I couldn't say angle R. Here we care about the order. They have to be correct. I will mark that wrong because that really matters. If you're writing computer code or what, that will make a huge difference. And that is because angle, angle, side, triangle, congruence. If you want to abbreviate and write it all out. Now really, my congruence should have more squiggly. It should be like that. It should not just be like a hump. It's an actual squiggly.
No, it's a mountain.
It's a mountain.
It's a mountain.
Any questions on that very short proof? Now up here we could have written P and T both equal 120 and PQ and ST both equal 6 is what would have been here in my okay, we had some info given. Now on mastery or things like that, we will want to be formal and actually write out given information, things like that. But we're just taking notes and trying to move kind of quickly. And that's one of the things, I do not teach this class how I would teach a standard class. Right? I teach you guys very unique based off us being a small group and so advanced. So suppose we're working on a problem involving two triangles, UVW, XYZ. You know UVW is congruent to XYZ. What else can we conclude? If we were to list things like sides, angles, all that, what can we relate to each other? So take a moment on your paper. I challenge you to list out everything we know.
As a group or individual?
Start individually, then you can chat with each other to check if you all have them. How many angle congruent statements should we write? Are we able to write? Not if we're listing out everything we know.
Oh.
We list out everything we know. How many congruent angles do we know?
Oh.
3 pairs, right?
Yeah.
angle U to X, angle V to angle Y, and angle W to angle Z. Right, so we would have 3 different statements of angle congruence. I just did not want to write them ahead of you guys. So we would say angle U congruent to angle X, angle V congruent to angle Y. I need to squeeze this in somewhere. Angle W congruent to angle Z. Any questions on those? Still taking the same order, which, by the way, there will be a question. Well, I haven't written your test yet, but I anticipate there will be a very similar question with, given this congruent statement, list everything you know. Because then, what if I start relating, like, I don't know, side VU? What would VU be congruent to? YX, right?
I was looking at the next problem.
And YZ? I just made my life a lot harder, right? I went from starting over here to starting over there. Don't do that. Make your life real easy. Take a walk. Okay, so I had a great math professor in college who would say like all these small little snippets. And one thing that he would talk with us for geometry is like, put yourself in it, right? Like imagine that you're there. If I started here and I first said V to U, keep going on that walk. Then say U to W, then say W to V. So I could just say U to W and then W to V before I ever move on to the other triangle. Start in the same place, right? I start here, YX for my first one, bless you, XZ for my next one, and ZY for my last one. Just take a walk, like literally follow the shape. So we would have 6 congruence statements based off 1 triangle congruence statement. Yes, most definitely. Why? Because you see a flow chart next, and you're like, let's get out of here before the flow chart happens?
Yes. Speaking of which, I'm going to go to the bathroom.
Okay, so Monty Python and the Quest of the Holy Grail. Anyone? Yes? Monty Python?
Yes.
So the part in the movie where they're all like, they think they're going to take on the rabbit, and then they're all like, run away! That's what I think it was, some hard math things. I'm like, no, we're going to come, let's go find the holy hand.
My favorite,
right?
I'm going to go sharpen my mechanical pencil.
Yes.
my favorite part in that movie is when...
So here's how this looks as a flow chart, right? Not that same problem, but here's what flowchart proof looks like and what we could use, but we don't necessarily have to. Okay, so Callie started a proof with the given information in the diagrams at the right. We see that AD is parallel to CD, or CB, sorry for the misspeak. And angle A is congruent to angle C. ADB is congruent to CD or CBD. ADB, okay, ADB, CBD. How is she making this statement? Alternate interior, right? Because this is our transversal. One of the things Dr. Smith would also say is if you're struggling in anything geometric, add a line. So if you want, continue these parallel lines, at least mentally, to help you be able to see that. Continue your transversal out. If you need help seeing that, now it should be easier to see the alternate interior. And then DB, sorry, BD. What is that property? Relates it to itself.
It's just
reflexive.
BD muscle.
So then, and this is also a reason I don't love flowchart proofs. How CPM starts your flowchart proofs is essentially saying don't worry about the reasons. Just if you know that you can say it, then you can say it. Right? So like here, this was given. Right? This is because of alternate interior. And this is because of reflexive. So if we were doing this as 2-column, we'd have each of those things on its own with the reason beside it, which I like better.
Why can't we just say BD equals DB is given because they're the same line?
So, like, of course that's given. I agree with you. I 100% agree with you.
That's like,
But from the mathematical side, like, of course, duh, in a way. So that's why we gave it a name. So it wasn't just like, well, duh, like for the reason. So instead of just saying, well, duh, we use the reflexive property to say, I understand, I'm just saying this thing is equal to this thing. But the main reason they're doing that is to be able to use it in both triangles. And another reason we do that is if order, like, of course BD is not different than DB. But when I look at it going from B to D versus going from D to B, yeah, it could be, yeah. And then they relate the congruent triangles. How? We have angles. We have
Angle side,
this
angle. Oh, yeah.
side has been given. Ah,
Angle side, angle side.
What?
What do you even talking about?
do we know lengths of this side and this side?
No.
No.
Oh, sorry.
But we do know this
Oh, they're parallel,
This.
not congruent.
and this.
Santi, you're a genius.
Side.
Angle side. Right? If I start here, angle side, if I don't use this, I just skip over it. It's angle side. Now, here's my big opposition to flowchart proofs. These actually go here.
Why?
And this is actually based off angle side. We can now make this statement. And then in between here, what actually goes there? This is your best friend, Cpctc. Corresponding parts of congruent triangles are congruent. So Cpctc is the statement we use after we prove the triangle is congruent to show something else we're trying to prove that's part of both triangles. So they wanted us to prove AB congruent to CD. To get there, the easiest way was, well, let's show the triangles are congruent, and then, of course, they're congruent. Any questions on this? With location being such an important thing, especially when we go to do stuff like this, AB comes from first last, CD first last. Right? They have to be same location. Preguntas. Means questions in Spanish, but it's more fun to say than the word questions.
Pregunta.
But you need your inflection still, because if I'm asking the question would be preguntas.
The third word of the 72nd paragraph of some random law.
Why are you asking this question, Chris?
Most likely.
So if you were in a high school class, I really don't think you actually asked that question if you were sitting in a room of sophomores.
No, but
Right? Alright, try these. They're in most of these, watch, I believe in all of them, are, I don't know how to put this in the right tense. There's information that you got to figure out in these images before you can relate the triangles congruent to each other, or find out that they're not. So dive into these.
Wait, is it group or find out that they can't be
Do I have to do Oh, wait, no, you already said no.
You can do a 2-column. I'm totally fine with you doing 2-column. I prefer 2-column.
Wait, is it group or individual?
Just start individual and then talk as a group or whatever. I mean, as long as we're focused on what we're supposed to be focused on, then we're fine. Like, I don't care if you're talking as a group or on your own or whatever.
Good morning. Please pardon the interruption. For our 7th graders, if you received a permission form from Columbus Public Health for the Yes group, please bring that form to the office if you have that in your locker or binder. Again, our 7th graders, if you have a Columbus Public Health Yes form, please bring that to the office. Thank you.
What did they do on Friday?
What?
Did they do anything special on Friday?
You guys were at Super Games.
No, the 7th grade.
Oh, no, we just had a day.
You guys didn't have a normal Friday though.
Actually, I think last Friday was our first normal Friday. Not that we never, we just don't often. What can be related in A? Okay, we have parallel lines. I could relate a side that's in both of them, right? AC and CA, or whatever you want to call it, that's in both.
The well-done theorem. Either angle side. Yes.
I want there to be a well-done theorem so bad.
angle AC is equal to angle AC.
There's no such thing as angle AC.
I'm inside. Do you even? Well, I mean,
Can I relate any other angles?
Alternate interior. Just extend that line between AC.
So, if I look at that, and this is my parallel, and my transversal, alternate interior, how so? So
angle cap
BAC.
is equal to DC.
So here
Yeah.
and here.
Yeah.
Ah, so in our proof, we will claim those two angles. So angle BAC. So beyond your given information, we're now relating BAC is congruent to DCA based off alternate interior.
I wrote alternate exterior.
Are we there yet?
Are we there yet?
What can we claim? Angle, angle, side, right? Angle, angle, side, going in order. So we can relate the triangles. Now, order matters, right? So if I'm going angle, angle, side, and I just use DCA, angle, angle, your order doesn't have to be the same as mine. It might, but it doesn't need to be. So if I go from that angle, B to A, C.
Well, we like to sit here so to cut and fuck.
And that's from angle, angle, side.
I did it Jack and pecan.
Back with 2 C.
Questions?
What is that noise?
It is the snapshot noise.
Why do you keep taking snapshots?
Because then it goes in the notes.
But everyone's here.
Yeah, I know, but then I have my own personal, here's what we did that day.
So when we mess everything up, he knows where we went wrong.
Or if I'm trying to compare from year to year, like where were we during this week of school?
Oh, that's quite true.
Now, Nitin immediately says that's not congruent.
It's not.
So we see vertical angles. Satya just said vertical angles.
Actually,
Which then, actually my third angle would have to be congruent as well.
because the Dolby angle was
Yeah. You guys know what? 5 and 4. Not
Ah, stop. They're congruent. Don't make assumptions. I will.
Hunter,
Oh wait, never mind. That's a 5 and 4. Oh.
what are these triangles?
Oh, right.
Similar.
They're similar.
Whoa.
I didn't. I
Hey. Now who's right side up?
Yeah.
Arrogance is the most dangerous trait to a mathematician.
I'm never arrogant. I'm better than everyone else.
Satya, that's why I win.
That's never.
Fight me.
I'm never arrogant. Trust me. I'm too good to be arrogant.
Bruh.
It's like I'm not arrogant. I'm too perfect.
Not anyway. They're not similar either.
No way. Right.
Why are we all looking so closely?
Right.
We're like,
Zero chance. Nope.
What if 2 equals 6? Crazy theory.
Now what about D? Take a moment with D.
Maybe, but
I mean, they probably
I don't wanna do
have
Pythagoras
three
theorem.
there, so it's
I mean-
not
I
need a calculator.
What's 13 squared?
169.
What's 12 squared?
144.
What's the difference between 169 and 144?
Oh.
Oh. Dang it.
Hey, look, we barely
25.
even thought.
5.
Which means that this must be 5, which means, Stephen, hypotenuse leg. Once we solve that, I have that other leg as a 5, and I can match those up. Now, this is the first perfect integer right triangle above the 3, 4, 5.
Yeah.
So our first perfect integer right triangle is 3, 4, 5. Our next is 5, 12, 13.
Wow.
What's the next
That is
one?
also the next one gonna be 13 something.
No.
10.
What is it?
All right, questions?
Is there pattern? Next one.
You got like 8 minutes to work on your homework.
Is there
Homework,
pattern?
yeah.
Here, I will search it. I'll search it. Don't worry.
Hooray.
Integer leg lengths right.
We need to actually get tested. Everyone bring it to the lunchroom for us so we can. No, you're just they're literally like paperwork. They're like 15 cents. Yeah, this costing us $2 from the dollar store. What a ripoff!
My whole life is a lie.
List of perfect right.
My whole life is a lie. I know you do the homework, but not something for $2.
Alright, I bet this. This I can't guarantee that this is accurate.
Oh man, it got it. It's sitting on
Gentlemen,
my
can I help you with something? Because you seem stuck. So is there something I need made aware of? Because otherwise it sounds like you're just like making fun of me. Which I don't care, but if you're making fun of somebody else, you should adjust that behavior.
No, so whenever someone's like, I bet I can do that, for some reason, everyone's like, bet, you won't, bet, you can't, you won't, big bet.
Does this relate to some sort of video like 21 did back in the day?
It's not even, it's just
We just like shouting better.
yeah, I bet you know.
Oh, that's easy.
Get it? Bet. Oh,
So
bet.
easy.
I hate sitting in my face. Am I though? Bet.
Oh, yeah, I can make the
End
whole.
this right now.
Big bet.
Wait, Miss Johnson.
Big
You know
bet.
in our homework we make the chart or whatever.
Yeah, hey, so again, in your homework, you made 2-column proof instead of flowchart.
So,
I think this might be a very interesting image of how the unit circle works.
what?
What
What is that?
So these are right triangles from the origin with certain leg lengths. Like, I doubt the image is good enough to zoom in on. But like, if you went from the origin out and made perfect, that's why this is so dense, is there are a bunch of perfect right triangles in there.
Yeah.
So that gets it like, it's just in the other direction. So it's not negative length, it's just directional. I'm not sure though, so like I would want to read this.
No, there's 5 different directions now. No, there aren't.
Hey, so negative values are included just to illustrate the parabolic pattern. That's why. That's why they put it on there. So it's negative direction, not length.
Have we found it in quadrants?
I mean, there's the third dimension.